For more than 3 centuries, astronomers could see that Iapetus was divided before they could explain why the divide seemed determined to survive. NASA's modern interpretation, supported by observations from the Cassini spacecraft, eventually revealed that the answer was not a painted surface, not a geological scar, and not a simple coating of dust. The visible divide was the aftermath of a process that changed the future of an entire moon. The image itself looks almost too simple. One hemisphere is dark, the other is bright. Not modeled, not gradual, divided. Seen from a distance, Iapetus appears as though someone drew a boundary across its surface and assigned each side a different world. The contradiction was visible long before the explanation. When Giovanni Cassini discovered Iapetus in the 17th century, something strange followed. At certain points in its orbit around Saturn, the moon was easy to find. At others, it seemed to disappear. Over time, the pattern became difficult to ignore. The moon was not vanishing. One side was simply much brighter than the other. The divide became evidence. Generations of observers could see the symptom. None could explain the mechanism. And the longer the mystery survived, the less likely a simple answer seemed. Because moons are not supposed to look like this. Most surfaces accumulate scars, craters, and variations. Boundaries soften, contrasts blur. Time usually smooths things out. Yet Iapetus preserved a hemisphere-scale difference so dramatic that it remained obvious across centuries of observation. The question was no longer whether the divide existed. The question was what could maintain it. Eventually, a convincing answer arrived. The dark hemisphere faces forward along Iapetus's orbit. Like the windshield of a moving vehicle collecting insects, that side encounters incoming debris first. Far beyond Saturn, among the planet's irregular outer moons, exists a source of dark material. Dust released into Saturn's system slowly drifts inward. Its path intersects Iapetus. For the first time, the geometry made sense. The leading hemisphere should collect more dust. The dark region should appear exactly where it does. The mystery seemed to be collapsing into a straightforward explanation. Iapetus got dirty. A centuries-old puzzle finally had a source. The dark side was not born dark. It was stained. And for a moment, that looked like the end of the story. Then the evidence began creating a new problem. Because a stain should behave like a stain. A thin coating should remain a surface feature. It should explain color. It should not explain consequence. Images returned by spacecraft showed something unexpected. Bright material remained visible beneath portions of the dark terrain. Craters exposed lighter material underneath. The dark layer appeared important, but it did not look substantial enough to account for the scale of the divide by itself. The contrast was simply too extreme. One side of the moon reflected light like fresh snow. The other absorbed it like asphalt. The coating explained how darkness arrived. It did not explain why darkness won. The investigation had not ended. It had only identified the trigger. The same black and white boundary returned, but now its meaning changed. It was no longer the answer. It was evidence that something happened after the dust arrived. The turning point came with a different way of looking at the surface. Not through color. Through temperature. Dark terrain absorbs more sunlight than bright terrain. That fact sounds almost trivial. Yet on Iapetus, it changed everything. The dark regions became warmer. The bright regions stayed colder. For the first time, the divide was not merely a difference in appearance. It was a difference in energy. The moon had developed two distinct thermal environments. And once that happened, the surface stopped behaving as a static landscape. The dark hemisphere became an active process. A small contrast in brightness created a measurable contrast in heat. The question shifted again. What happens when one side of a frozen world remains consistently warmer than the other? The answer was not found in the dust. It was found in something disappearing. Water ice. Across the warmer, dark terrain, ice gradually escaped the surface through sublimation, changing directly from solid to vapor. That vapor did not vanish into space immediately. Some of it migrated. Some of it settled again in colder regions. And the colder regions were mostly the bright regions. The moon had begun redistributing one of its most important surface materials. Ice left the warmer areas. Ice accumulated in the colder areas. The divide was no longer being preserved. It was being amplified, because reflective ice performs a second role. It keeps surfaces cool. When ice disappeared from dark terrain, the exposed ground became even darker. Darker surfaces absorbed more heat. More heat encouraged additional ice loss. Additional ice loss exposed even darker material. The process fed itself. A small initial difference became self-reinforcing. The dark hemisphere warmed. Ice retreated. The surface darkened further. The warming increased. The cycle repeated. The moon was changing the effect of the original contamination. Every step strengthened the next. The same boundary that once looked like a stain now looked like a migration front. A moving contest between darkness and ice. And each round favored separation over blending. The consequence accumulated over immense spans of time. Not because the dust continued arriving in enormous quantities, but because the moon's own thermal behavior kept reinforcing the contrast. The trigger was external. The transformation became internal. By the time the chain reaction reached maturity, the visible result stretched across an entire hemisphere. The divide survived because the system rewarded the divide. What began as contamination evolved into feedback. And that feedback reorganized the appearance of a world. The black and white image returns one final time. At the beginning of this story, it looked like a mystery. Then it became evidence. Then it became a stain. Then it became a thermal imbalance. Then it became a feedback loop. Now it becomes something else entirely. A record. The dark hemisphere is not merely where dust landed. The bright hemisphere is not merely where dust did not land. Together, they preserve the history of a chain reaction. A small imported layer altered how the surface handled heat. Heat altered the distribution of ice. Ice migration strengthened the contrast. And the strengthened contrast accelerated the process that created it. The divide did not simply survive. It helped preserve itself. What observers recognized centuries ago was real from the beginning. They correctly identified the symptom long before they understood the mechanism. Iapetus is not remembered because one side became dark. It is remembered because a thin stain arrived on a frozen world and somehow persuaded the rest of that world to reorganize itself around a single line.